I have just set this up to show that the copper sulfate electrode, known as a half cell, is not a stable potential. I've done this by putting a wooden rod into a saturated solution of copper sulfate. You can see it's saturated because the crystal's at the bottom. I've put a copper piece of wire, which must be pure copper, otherwise the wire wouldn't be as specified. I have connected just the wood and the copper to my multimeter. When I connected it with the red wire in the active and the black wire in the common, it showed a reading which was about 0.36 volts. That's 360 millivolts approximately. When I changed the wires over, the reading appeared exactly the same, but then very quickly reduced and went negative. Now, I'm going to change the wires back to their original position and you will see what happens. So I've unplugged the wires. I'm putting the red in the active and the black in the common. And now you can see that the negative value is reducing. I will leave this on to see if it goes positive. It's gone positive, but this is interesting in that it should immediately change to positive. And in fact, what is happening, it is slowly going positive, and we will see what value shows on the meter. This could mean that the structure that I have put in here of the copper sulfate and a porous connection to this side and the copper wire connected directly to the active connection, it could mean that this has some sort of capacitance, which is actually gradually changing from the positive reaction to the negative reaction. On the meter, this is. We can only go with what is on the meter. Now at a later time, I'm going to test this out with my oscilloscope and with two other meters in circuit so that I can make a proper record of exactly what this phenomenon is. I'm going to switch the meter off now. It's gone from negative to positive 121. I'm going to switch the meter off and then make another video when I switch it back on again. The meter is off, as you can see, but the wires are still connected in the measuring circuit.